In this video, we are going to talk about symmetry of graphs about x-axis, y-axis and origin. First, we will discuss symmetry of a graph about y-axis. Let's say we have a graph y is equal to f of x. And we want to check that if it is symmetric about y-axis or not. Now, let's have a look first at a graph. If we look closely, we will see that this graph seems to be symmetric about y-axis. Now let's consider a point here. This point, let's say it has coordinates x, y, and corresponding to this point x, y, on the other side of y-axis we have a point on the same graph as minus x, y. So see, this graph is symmetric about y-axis, means whatever is the shape on one side of y-axis, the same is the shape on the other side of y-axis. And the point xy which lies on the graph and the point opposite to xy on the other side of y-axis, which is minus xy, also lies on the graph. So we are going to say that if a graph is symmetric about y-axis, then for every xy that is lying on the graph, minus xy also lies on the graph if the graph is symmetric. Or we will say that if replacing x by minus x, the graph y equal to f of x remains unchanged, it means that the graph is symmetric about y-axis. Means for every xy point that is lying on the graph, minus xy also lies on the same graph. Or we can simply say that if we replace x by minus x and we get back the same shape, means the same graph that we started with, then we will say that the graph is symmetric about y-axis. Let's look at the example, the same example that actually we have seen geometrically. So if we have a graph y equal to x here, and mathematically if we are not looking at the shape, because if you are looking at the shape you will immediately guess that the graph is symmetric about y-axis or not. But mathematically, how do you have to check that? So we know this rule that if we replace x by minus x, and if making this change gives us the same graph back, we will say that our graph is symmetric about y-axis. So we have replaced x by minus x. So it means that we get back the same shape. So we will say that our graph is symmetric about y-axis. Let's try another graph. So we want to check that if it is symmetric about y-axis. So we will replace x by minus x. It gives us minus x cube. So we started with y equal to x cube and we got y equal to minus x cube. Our graph did not remain unchanged. So we will say that this graph y equal to x cube is not symmetric about y-axis. So let's try symmetry of a graph about x-axis. Let's roughly have a look first at a graph this one. Now please see this. If I am considering here a point xy, and on the other side of x-axis on the same graph we will have a point, but what would be its coordinate? Since x has remained unchanged, x is same, but y has come down, so it is minus y. Now if we just look at this shape, we can see that this graph is symmetric about x-axis. Whatever is the shape above x-axis, the same is the shape below x-axis. And we can also see that if for this symmetric graph about x-axis, the point xy is lying on it, then on the same graph x minus y lies on it. So we can say that a graph which is symmetric about x-axis, for every xy, x minus y will also lie on it. Or in another way, we'll say that the graph is symmetric about x-axis if replacing y with minus y keeps the graph unchanged. So let's look at the example. I don't have the shape for this graph before me, so I will have to test it mathematically, that if this graph is symmetric about x-axis or not. So we know the rule that if we want to check that if the graph is symmetric about x-axis or not, so replace y with minus y. If I get back the same graph, I will say that this graph is symmetric about x-axis. So let's replace y with minus y. This equation, it is minus y plus minus x. This gives us y. I'm keeping y on one side and taking minus on the another side. So we got back the same plus minus x, because this minus here multiplies with plus gives us minus, and this minus multiplied with minus gives us plus. So again we have plus minus x. So the shape did not, the graph did not change. So we will say that this graph is symmetric about x-axis. Let's try another graph. And let's check if it is symmetric about x-axis. So what do? We replace y with minus y. So just remember that if we are checking the symmetry about y-axis, we replace x with minus x, and if we are checking the symmetry about x-axis, we replace y with minus y. So here in this example, for y square equal to x, we are checking the symmetry about x-axis. So we have replaced y with minus y. Let's do that. Minus y whole square equal to x gives us y square equal to x. So we started with this graph, we got back the same graph. So we will say that yes, it is symmetric about x-axis. Okay, so let's now check symmetry about origin. Before we define this, let's have a look at the graph. Let's say we have this shape. If we have a point here xy, opposite to this, if we have a point here now, its coordinates would be, because now this x is on another side of x, so this is minus x, and this y is down below here, so it is minus y. So now see, in this graph we say that for every xy, minus x minus y also lies on the graph. For example, if xy is here, minus x minus y would be here. So this kind of a graph where for every xy the point minus x minus y also lies on the graph, on the same graph, we will say that that graph is symmetric about origin. Or we can say that if replacing x y by minus x minus y keeps the graph unchanged, we say that the graph is symmetric about origin. For example, now let's look at this graph mathematically. So we want to check that if it is symmetric about origin. So what shall we do? We replace x by minus x and we replace by minus y altogether. And if replacing x by minus x and y by minus y keeps our original graph unchanged, we'll say that it is symmetric about origin. Let's do that. So y is minus y and x is minus x, gives us minus y equal to minus x cube. This minus cancels out with this, so we have y equal to x cube. We got back the same graph. So yes, it is symmetric about origin. Let's try one more graph. We have to check that if it is symmetric about origin. If it is symmetric about origin. So replace x with minus x, replace y with minus y. If we do that, so this is what we get for our graph. Simplifying it gives us y square plus x square, gives us the same graph back. So yes, this graph is also symmetric about origin. Let's check one more graph, a very simple one. We want to see that if it is symmetric about origin. So replace x by minus x, replace y by minus y, and what we get is minus y equal to minus x whole square. So this minus goes on the other side and minus x whole square gives us just x square. So the original graph was y equal to x square, but now we got y equal to minus x square. So we got a different graph. So this case we will say that no, the graph y equal to x square is not symmetric about origin. And sometimes we can decide if a graph is symmetric about origin or not just by looking at the shape. So if we have this graph, let's say it's a circle, you can see that if it is symmetric about origin or not. Yes, for example, for this part, its symmetric part about origin is this one, and for this part, its symmetric shape about origin is this one. So yes, this whole graph, which is a circle, which is this one, and we have already mathematically checked that replacing x with minus x and y with minus y does not change this graph. So this graph is symmetric about origins. So in the next video, we are going to talk about even function and odd function.